Hello everyone. Today we are going to talk about asynchronous JavaScript, what are the options and how to use each of them. But in order to fully understand the process, first we need to see how JavaScript works under the hood. The very first thing we need to understand is the fact that JavaScript is single-threaded. While many other programming languages have built-in multi-threading features, JavaScript keeps it plain and simple. But if it runs on a single thread, how does it manage all these user interactions or data fetching without constantly freezing everything? Let's find out. So we have a browser, a complex piece of software that includes many different elements. But we are particularly interested in JavaScript engine, the thing that allows browsers to execute the code and serve as a runtime environment for JavaScript. It contains an important element called call stack, which is responsible for managing the execution of our program. It tracks our position in the script, the function currently being executed, and any other functions called from it. When the script invokes a function, it is added to the call stack and the execution begins. When it is finished, the function is removed from the call stack. If any function is being invoked from the current one, it is added on the top of the stack and the execution is transferred to it. Then, when it's finished, the engine returns to the parent function and continues from the place it left off. Okay, so we have just witnessed how typical synchronous code works. Now let's see how asynchronous one is executed. Let's use setTimeout method and print some text into the console after 1 second. As we can see, even though we have synchronous code after setTimeout, it is not blocked by it and gets executed immediately. Well, it's all thanks to a few additional components of the browser: web APIs, task queue, and event loop. Web APIs provide us with additional useful features we might need to use in our web application. Features like manipulating DOM, fetching data, etc. setTimeout is the method of the window interface. Its job is to register the callback and the delay. After that, setTimeout is removed from the call stack and the actual countdown will be done by the browser in the background. But then, when time is up, we need to execute the callback. And you can imagine if it would force its way in, ignoring any ongoing logic, it could cause an entire cascade of unexpected behavior and bugs. That's why there is another component called task queue. When time is up, instead of pushing the code directly onto the call stack, it is added to the task queue where it will wait until another component called event loop will pick it up. Event loop has one job only: constantly check if the call stack is empty or not.
What is my purpose?
You pass tasks?
Oh my god.
Yeah, welcome to the club, pal.
If it is empty, then it pushes the code from the task queue onto the call stack. And just like that, we have non-blocking single thread, which is capable of executing asynchronous code. Now, there is one more detail. What do you think will happen if we use setTimeout with 0 milliseconds delay? Well, the code inside of it still gets executed as the last one. Why is that? The reason is that when script is first loaded, a so-called global execution context is created and pushed onto the stack. Kind of like a main function which stays in place until the entire script is processed. I didn't mention it earlier, so it would be easier to visualize the call stack, but if you don't know about its existence, such edge cases might be a surprise for you. Just remember that because of that, the asynchronous code will be executed only after all of the synchronous code is processed. By the way, this is also a good illustration why setTimeout is not the best choice when it comes to precision. The provided delay specifies when the task will be added to the queue, not when it's going to be executed. If there is a really long synchronous code, a synchronous task will have to wait, potentially for quite some time. Okay, now in terms of handling the asynchronous logic, we have a few options. First is the old way of simply using callbacks. Let's say that we have a few asynchronous functions and we need to invoke them in particular order. Well, all we need to do is to make sure that those functions accept callbacks and then we just invoke them in the order we want to implement. But the problem with this approach is that it can lead to callback hell. In our case, we have just 3 functions, so it's not that big of a deal. But if you would have really complex logic with a lot of functions, that could become unreadable pretty quickly. So, to solve that issue, we can use promises instead. They might be a little bit confusing when you see them for the first time, but if you get the concept behind them, it's really simple. Let's take a look. So, a promise expects just one parameter, a function called executor which will be running your code. But that function itself has 2 functions as parameters. They are usually called resolve and reject. You are supposed to invoke resolve when your logic finishes successfully and reject when it doesn't. Both of them can take a value which will be returned when they are called. Let's define a function which returns a promise. Now we can call .then method which contains the logic that will be executed after the promise is resolved. So here we can put some callback function and it will be executed. In addition to that, we can access the value that was passed inside resolve function. In case of reject, we have .catch method, which also takes a callback to be executed and can access the value passed from the reject function. Now, there is also one very important detail. Since code inside then and catch is not executed immediately, but rather sometime in the future, when promise is resolved or rejected, it is also added to the queue. However, promise-based tasks are handled by different component called microtask queue. And this one has priority over regular task queue, which means that event loop will first push all microtasks onto the call stack before it will start processing any regular tasks. Okay, so now when we know how to work with promises, we can get back to our previous example with bunch of tasks, and instead of dealing with callback hell, we can use nice and clean method chaining. Now, promises have a lot of other useful methods, but most of the time you will be working with .then and .catch. So it's all very nice.
But it can be better.
In terms of readability, we have even better option, async await. It is basically a syntactic sugar which makes our life easier. To start using that, all we need to do is just to mark our function as async with dedicated keyword. Then inside of such function, whenever we invoke a promise-based function, we just add await in front of it and that's it. The next lines of code will not be executed until such operation is complete. And as you can see, in terms of readability, it's virtually indistinguishable from synchronous code. Well, that's all folks. I hope this video was useful for you, and now you have a better understanding of asynchronous JavaScript. If you enjoyed the video, please leave a like, comment, and of course subscribe for more. Bye!